This is really good for one reason I'll tell you here in a moment. And the decode is more memory heavy. This is the concept of, so when you send a prompt to something like GPT, for example, Chat GPT, there are two major phases that happen. The first major phase is that model is going to go through everything that you have submitted. So if you're sending let's say an email to summarize, it's going to go through all of that email in its first pass. It's going to load that into the KV cache, and it's going to create all the necessary weights and inference that need to happen. And then there's a second phase. So that's what we call the pre-fill phase. Second phase is when you see ChatGPT like giving you word by word, that's what we call the decode phase. And it does that iteratively over each word that it's predicting. And what we have found is that the pre-fill side is very compute heavy. This is really good for one reason I'll tell you here in a moment. And the decode is more memory heavy. What's cool about this is that we can actually leverage the CPU. We find CPU actually can work pretty effectively at doing the pre-fill. What CPU doesn't do very well at is the decode. So I'll give some examples here in a moment, but that's kind of something I'm leading to here, is that by actually splitting some of this up, not only do we get to treat it more like a microservice, like a first-class citizen, but we also get to treat all the different stages of the LLM and actually assign it to different infrastructure components and different AI accelerators, or even CPU-based computation by breaking that all up. So that's one major aspect of being able to break this up into what we call disaggregated inference.